All right, so let's consider this example here. We want to find the area inside the right lobe of r equals the square root of cosine of 2 theta. Okay, so let's go and take a look at the graph and see exactly what it's talking about our right lobe, and then also, what can we get as far as limits of integration. How are we going to integrate? So I've gone ahead and put in my function here. Now again, Desmos will automatically graph it, and it'll show you the upper constraint and the lower constraint for its polar coordinates. So it'll show you those limits. But I've gone ahead and set it to A, and I know from what I saw previously that it is 2 pi. Okay? So let's just go ahead and look at what we get when we start graphing. First of all, there's the whole graph. So we're actually graphing infinity. That's kind of cool, right? Here we actually have what looks like a very nice shape for infinity. The square root of cosine 2 theta makes a really nice looking infinity symbol. Okay, that aside, here we're talking about the right lobe. So we're talking about just the one loop of the graph, the right loop, or right lobe. So we're not worried about this one here. We're just worried about this one. So how does it come about? We can definitely see that there's symmetry. So if we can just find the area of this top half of it, we could just double it. So let's see how it works. So as we start graphing, incrementing through there, 15 degrees, 30 degrees, 45 degrees. At 45 degrees at pi over 4, we've actually finished that first half of the graph. And then as I move nothing's graphing. Why not? Well, because now we're into the second quadrant where cosine's negative, so the radius is undefined. So nothing's happening for a while. In fact, nothing will happen again until 2 theta puts us back into the fourth quadrant. Or, in other words, 2 theta has to be start being equal to 3 pi over 2, which means theta would have to be equal to 3 pi over 4. And that's actually when you'll start seeing, there we are at pi over 2, keep going, and now once we've hit 3 pi over 4, we start to see some more graphing. That graph will continue. Once we reach pi, we continue. Now, 2 theta has actually made its second trip around, and 2 theta has actually now reached pi over 2 again. And that's when we stop coming out. Theta has actually reached 5 pi over 4, which means 2 theta has actually reached 5 pi over 2. So once again, we're into the second, third quadrants. As far as cosine part of that stuff is concerned, we're negative for a while again. And we keep going until eventually at the very, very end, we finish off the graph. Okay, so these two things are completely disconnected. This part and this as far as interval-wise. As far as interval-wise, they're pretty disconnected there. We could do it as two separate ones, but that makes no sense. It makes much more sense to just do the integral of this first piece. And we can get all of that just by going between 0 and pi over 4, and then double it so that we can get the whole lobe. Doubling it so we get the whole lobe. So that's what we're going to do. So our function is just r equals square root cosine of 2 theta. And we're now going to double that area and integrate from 0 to pi over 4 of 1/2 of our function squared. And we go ahead and simplify. The 2 into 1/2 cancels out. Square root squared. We'll have the integral from 0 to pi over 4 of cosine of 2 theta d theta. But hang on to that d theta for a second, because we would let u be 2 theta. du is going to call for a 2d theta. So I'm going to need 2 to go with my d theta. So 2d theta. That means I'm going to need a 1/2 out front. Now everything's set up so my integration will carry straight through. Integral of cosine is sine. So that would be 1/2 sine of 2 theta. Evaluate it between 0 and pi over 4. And when you evaluate that, twice pi over 4 is pi over 2. Sine of pi over 2 is 1, so that would just be 1/2. Sine of 0 is 0, so that's minus 0, so the whole thing is 1/2. So the area of that right lobe is 1/2. Of course, by symmetry, the area of the left lobe would also be 1/2. So the area inside my infinity symbol here is 1. The area inside my infinity symbol here is actually just 1, if that's what we were being asked about. But we were just asked about the right lobe, so the area is 1/2. The area is just 1/2.